Hi, everyone. Thanks for the introductions. Really great to be here. Thank you for the opportunity to speak today. Really proud to now show you what we have here at a waters company. So I just recently have new colleagues, and I'm really happy to be part of this presentation. I'm Jasper Eaton, your sales representative for Andrew Alliance, now a waters company. And today I have a short moment to show you the Andrew Plus instrument working live. So here's my little friend here, and the OneLab software that really ties all of this together in terms of cloud-based protocol design and smart connected instruments actually executing those protocols downstream. So that will be the presentation that I have for you today, working live, the Andrew Plus instruments, and OneLab. So we'll dive right and show you the robot actually executing a protocol live. So just before that though, one quick thing, we'll talk about what this instrument actually does, where it sits in the marketplace, and essentially how it works. So it's three parts. So let me just mention that really quickly before we get started. What we have is the main core of the instrument. This is the Andrew Plus robot, right, as I mentioned. And we have three other components that really describe what it does. So on the left there, we have a static arm, so we can't really see it here, it's a bit hidden. Right there is a static arm that essentially holds the pipette in place, so holds the series of pipettes in place in order to be able to use them in a automatic way. So you choose your volumes, you choose whether you want a single channel or multi-channel, and the robot will work with them from there. Second part to this instrument is this mobile arm that you see here straight in front of us all. This is the arm that will actually be doing the heavy lifting, be doing the work, right? So he's going to be grabbing the pipettes that are needed from that stationary arm. So whenever a pipette change needs to happen, this is doing that, and then communicating directly with the pipette to automate the process. So that's the second part of the instrument. Third and last part of the instrument that has a very strong importance here in this protocol that I'm going to show you today, and in all protocols with Andrew Plus, are these little blocks here. These are called dominoes, and they essentially create the interface between a consumable, in this case, 96 well PCR plate, right? So the interface between this consumable and the robot. So these little dominoes here really do thanks to these QR codes that you see on my video feed right now. This is positional information, but also consumable information. So the robot knows what he's working with and where it is exactly in front of the space. So these are individual magnetic tiles that connect one to the other with a snap magnetic connection. We can have up to 11 of them in front of the working space of the robot simultaneously. So up to 11 means that we can put all 11, or we can put less. Maybe we want to only put 4, maybe only put 5, if you see what I mean. So this really builds out like a puzzle and creates the bench of the instrument. So without further ado, I'll get started on launching the protocol again. So I had it just in the interest of time. Let me press on. So what I wanted to show today was just a quick protocol. It really kind of shows the different features of the instrument and how it works. So there we actually see that static arm, there it is, that was hidden before, holding the pipettes that are needed for this particular protocol. And now what I want to show you is the ability of this instrument to create a serial dilution. Pretty simple, straightforward application that we all know about. How does it do that? These pipettes manufactured by Sartorius, our partners, directly for Andrew Alliance, are actually equipped with something that's pretty special, a Bluetooth chip, and updated firmware. That means that these connected electronic pipettes will directly be communicating with robots in order to execute this protocol. So everything that's volume changes, aspiration speeds, injection, air cushions, all of this is directly sent to the pipette via Bluetooth to the robot that's connected to our cloud-based software. And I'll show you that software and coming full circle as to how I actually created this protocol at the very end of our discussion here today. So the pipette here is capable of repetitive dispensing, so with small volumes and volumes, in order to create a seamless serial dilution as you're seeing right here. So mixing as well. Just let it pause a little bit. I'll stop talking. So you can really see the mixing step here. So critical to serial dilution. Every time the robot will be doing the same mixing step, and this is so important when we talk about reproducibility, precision. That is really important. So let the protocol keep going here. Essentially, this instrument will really communicate with all of the devices that it has here. So what we have in front of them so far for this particular protocol are simple standard dominoes, as I mentioned, that create the interface between labware and instruments. But this can be much more complex than what you see here today. And I'll explain what I mean by that in the software. We can add, so not just static dominoes, but connected devices. So a connected device, essentially another type of domino that actually has a function to it other than holding the consumable. I'm talking about a Peltier device, for example, for heating and cooling between 0 and 90 degrees approximately. We have a shaking device, so the Shaker Plus device, that will just the same sit right in front of the instrument right there and be used during a protocol. A vacuum manifold, so it was mentioned before that we do have SPE ability with the Andrew Plus instrument, and that will be thanks to the Vacuum Plus device that will sit here just in front and be fully controlled wirelessly with by the instrument through OneLab. So here what we just saw was a pipette chain. The instrument is capable of taking the pipette that it needs for a particular protocol run. So there's very little human intervention that needs to happen. I just need to make sure that I'm setting up my protocol properly, and the robot will do it. We'll take it from there. Here, also what I wanted to show was the ability of Andrew Plus to work with larger volumes, in this case a 10 milliliter pipette. We are pretty much the only company to be able to do this with liquid handling and do dispensing as you're seeing right here. This means that we have really a wide range of applications that are compatible with the instruments because we cover a wide range of volumes and also a wide range of compatible consumables as well. Just a quick note about the pipettes, other than the Bluetooth connectivity. They do have they go from 0.2 milliliters all the way up to the 10 mLs that I just mentioned, with of course the ability, as you just saw, to use 8-channel pipettes as well. So from the same volume range all the way up to 1.2 milliliters with that purple pipette right there. So there we go. The instrument has completed its run. It's ready to go. It has signaled with a little bit of light and sound that he's done. But here's really the cool part, is I have full control over what just happened in real time, thanks to OneLab. And so what I'll do in just a moment is share my screen. So give me a second. I have my little computer here. All right, so now everyone should be seeing my screen, ready to go. And what you're seeing is actually going to be really a parallel between what we just saw with the automation execution, thanks to Andrew Plus, and protocol writing, so protocol design here on my computer screen. So what I'm looking at right now is actually my validation report, so my log report of what just happened. And the first thing you'll notice is, of course, that this experiment was luckily finished with absolutely no errors, and that's really good news, but also a lot of really critical information. If there were to be an error, for example, it would show up here, and this is really important. We know who set up that experiment, which instrument was used to set up that instrument to create that protocol, which pipettes were used, so their serial numbers, even down to the time that they were last calibrated, if we need to go up in that traceability log reports. And I can just go ahead and validate that, and it'll be stored automatically for us in the cloud if we need to have downstream access. This brings me to my OneLab screen. It looks like my colleague Tom needs to update his pipette firmware. I'll let him know that he can do it. He's probably sleeping right now in the US. So we've got here OneLab, and the first thing you'll notice is at the very top left here. I am actually on onelab.andrewalliance.com. So I'm not on any kind of downloaded software that's specific to my computer. I'm on web-based browsers. So I'm actually signed in with Google Chrome, but you can use Firefox, Safari, Microsoft Edge, any of these web browsers or any computer, tablet, or smartphone that can connect to internet can connect to OneLab, can design a protocol, and can execute it. So that's really the objective of this cloud space here. So that's the first thing. Next thing that I want to bring your attention to here with OneLab is actually the ability to really do much more than just program liquid handling instrumentation like Andrew+. OneLab is really designed as a universal space for laboratories to create their protocols, share them, and execute them in any way that they see fit, whether or not that includes liquid handling like Andrew+. It's really a space for connected sharing and execution of protocols. We know very well that there's a lot of issues with reproducibility in large companies. For example, reproducing the same protocols is so difficult. So having this workspace where we're all doing the same protocols is so critical. So moving on from there, I always like to talk about this software as having a three-pronged approach. The first is, of course, designing those protocols that we have in the lab, universal protocols. The second approach is that traceability that I talked to you about just before. It's being able to connect different users all together in the same space, executing the same protocols, and really having user management to know who can do what and if they can do that. So we see here that I'm part of the sales lab. I can manage my members in this workspace. See that I have administrative rights in which of my colleagues have the same rights or not, whether they're just members or operators. So I really have that full traceability thanks to user management here. And lastly, being able to execute experiments. So executing and designing experiments is completely regardless of the kind of instrumentation that you have downstream to automate it. And I'll get to that point in just a second. So one more thing. The 4 tabs at the top of this software are quite important. They really guide you through the whole process. So I'm on my home page right now. So I have quick access to everything that's going on in my lab, so the sales lab in this, in real time. Next tab is my projects tab. This is a way of organizing my protocols all together to avoid any kind of cluttered workspace. It's quite important. So I can really have a quick look at all of my different colleagues' workspaces. For example, this is the way that we wanted to organize it. But you could very well have a space of in-progress protocols, finalized protocols, etc. Before last tab up here is my devices tab. Remember how I mentioned that OneLab is actually much more than just a space to create protocols for Andrew+. Well, it's true that today it is a space to create protocols for Andrew+. It will be much more than that. And here in this connected devices page is really where we see that come to life. So we have different tools that are available to execute these runs. Some of those are Andrew+ instruments, of course. Some of these are Pipette Plus instruments. So this is essentially a smart connected pipetting stand where instead of the robot being the arm, you are the arm, and the pipettes are being controlled by the software with automatic volume changes, specifics for volume, for well positions, excuse me, and really fully traceable manual pipetting workflows that we are the only ones to be able to do here with the Pipette Plus. So scrolling down here, I have a bunch of other available instruments. Notice here that we have a microplate shaker. So this is one of the connected devices that will sit in front of the Andrew+ instrument, for example, in order to automate a more complex run than just liquid handling. Keep scrolling down here, and we'll come to the Vacuum Plus station, another connected device that sits in front of the robot, communicates wirelessly with the cloud in order to execute these SPE runs, like GlycoWorks, for example. Last but not least, the library tab here at the top. Click on that. Here is an online library workspace where we have validated protocols from both us here at Andrew Alliance and our trusted partners. So here will be a space where protocols can be used as templates for you to download and work from. So if you see something that is of interest to you, you can just copy it to your OneLab workspace and use it directly as a template for your specific workflows, as opposed to starting a whole protocol from scratch. So here are some examples: BCA, DNA sequencing, ELISA testing, which is a great opportunity for Andrew Plus instrumentation. Library quantification. Keep scrolling, the list goes on, and all of these have several protocols inside them that you can work from. CyberGreen RT-qPCR, and most recently with our partner VelitaCell for IgG antibody quantification. So all of these are ready to go to be used in your OneLab workspace as templates as you see fit. So let's get back into the fun part of actually writing a protocol and coming full circle to how we executed it with the instrument afterwards. So I'll just go here into my projects tab, scroll down to my workspace, sign in here, and design a new protocol. This brings us to our protocol designer, which is essentially a workspace that allows you to create your protocols from start to finish in a very simple and intuitive way. So here on the left, we have different actions, labware actions, pipetting actions, and all of the different possibilities for protocol design that are here on the left. In the middle, we have a big white virtual bench space that will become kind of our chalkboard to write our protocol from start to finish. And on the right, of course, our steps that will add up as we create our protocol steps one after the other. So the software here is prompting me to start adding some labware, only reasonable, right? So I need to actually start working with some physical tools, right, before I can actually start pipetting or start doing my protocol. So let's keep it simple here for today's demonstration. But what we're seeing in this list is essentially a whole selection of all of the different kinds of consumables that are today in our software. And the objective is really to have everything. We'll never have everything because there are just so many, but here's already a very, very comprehensive list. Feel free to use some of the filters here on the left to find specifically what you're looking for, whether it's by manufacturer, if you know specifically which manufacturer you're looking to find your plate from. We do have a partnership with Brooks, for example. I can always scroll down here and have the software show me only consumables that are today compatible with the Andrew Plus, or essentially consumables that have a domino created for them. This is important for compatibility reasons. And select the labware that I want to use today. I'll add those to my bench space, and here they are. They appear as a very visual representation, and this brings me to my next point. What you see here on my screen is essentially what you would be seeing as an operator ready to launch their experiment manually. So you have your Falcon tube, you have your 96 well plate, your multi-channel reagent reservoir, and you're ready to go. So whatever you'd be doing, writing these steps, just think about what you'd be doing manually in your protocol, and it will come true here. Don't think about what happens downstream when it comes to automating with an Andrew Plus, for example. Just think about what you as a user want to accomplish with this protocol. So I want to add some substance into my Falcon tube to get started, right? So we'll let this page load, giving us a lot of different options for different things that we can put inside that Falcon tube to get started. And the objective will really be to use that starting point as a reagent or water. So I'll select some water here. Use this as a starting point to create my protocol. So where do I do from here? I think you'll see where I'm going to go with this, but what do I do from here? Creating a pipetting step is as easy as doing a drag and drop. So I'll take from my source, go to my destination, drop my mouse, and the next window that automatically pops up is all of the parameters, all of the configuration parameters of that given pipetting step. So here again, think about what you would be doing manually with that pipette. How would you be doing that particular protocol step? First and foremost, obviously, is, well, what volume do I want to transfer from position A to position B? Pretty reasonable, pretty logical, right? Scroll down here, and I see everything that's associated with doing that. How do I want to do it? Do I want to do it with forward pipetting mode, reverse pipetting mode? Depending on the substance that I'm working with, do I want to aspirate maybe a little bit more slowly in order to optimize my precision? Do I want to dispense more slowly? Do I want to add some air cushions maybe in order to optimize working with complicated substances, whether they're volatile or viscous? Where do I want to pipette from? Where do I want to pipette to in terms of tube depth or well depth? Do I want to go to the bottom? Do I want to stay following that liquid level as it aspirates? Or do I simply want to select on the fly in order to avoid any contact with the potential substance that may be already inside my well, for example? Do I want to change tips? Do I want to not change tips? All of these options here, like mixing, so up and down pipetting essentially, at my source or even at my destination is possible. So I'll go ahead and save that step. And here it is automatically written as step 1 in my protocol. So we'll let that load real quick. Perhaps the next thing that's important to show here as we create protocol steps is the ability to do not just pipetting, but much more than that. So now I have step 1 that's ready to go. Of course, I'll keep going here because the next thing I want to show you is some actions. Keep going here by, as you would expect, putting some solution from my reservoir to my 96 well plate. So another drag and drop. Select my destinations in my 96 well plate. There it is, all full. I can always copy and paste if I already have a predefined plate format that I want to fill. Save that selection, choose a volume, and we're back into this window here where we select how we want to do that. Maybe the only difference here is I'd want to go faster. So let's use repetitive mode that I just showed you before, dispensing from a larger starting volume, and save that step. So now we have step 1, step 2, and it looks like we may need to refill that. And so this is a step that I created. We may need to refill that into our reservoir to keep going. Now, last thing I'll show you before we click on this big green execute button at the top. I'm sure you want to see what happens next. Last thing I want to show you is this little window here. OneLab is designed for universal protocol creation. So it does not include just liquid handling. Everything I showed you right now is only pipetting here at the top left. But we can do much more than that. Imagine having a concentration normalization wizard that just automatically calculates the volumes that need to be transferred in order to normalize your concentrations. NGS, for example, proteomics, genomics. All of these applications could require this really tedious and long protocol to accomplish. OneLab does it in the bat of an eye. Some serial dilutions is what I showed you just before. And these 4 that I'm hovering my mouse over right now, these 4 here, actually today have connected devices that can sit in front of the Andrew Plus instrument and be fully integrated into the Andrew Plus OneLab workflow. So, first example, magnetic bead separation. Second example, that Vacuum Plus device that I just talked to you about before, SPE protocols. It's there. Third example, shaking, so homogenization of plates. And last but not least, Peltier device for heating and cooling. This is really active temperature control of your plates. So all of those 4 devices that I just mentioned will sit in front of the Andrew Plus instrument and be fully integrated into the workflow. Now imagine one thing. If we need to move a plate from one position to another, the robot can do that. So if we want to move, for example, from the shaking device to the Peltier device for heating and cooling it right afterwards, we can do that thanks to a plate gripper that will sit on the arm of the instrument right there, and the robot will automatically, without creating the step, the robot will automatically use that device in order to use that tool, in order to go from one position to another in front of the robot. And you won't have to program anything. So always stay focused on you can always stay focused on what you want to achieve with your protocol. Don't think about programming automation. You are doing it right here. So closing out of this, next step here is executing, and we'll come full circle. So by clicking on that button, essentially what I just did is trigger a search through OneLab to communicate with all of the connected devices in my lab ecosystem, right? So the robot is one of them, is an option to execute this experiment, and other tools can possibly be found here. So that's Pipette Plus, for example, the smart pipetting stand that I mentioned before. But of course, only if the correct pipettes are available in order to execute the protocol. In this case, it looks like That 10 ml pipette is not on my colleague Alma's Pipette Plus station, so it can't do it. If you were to put that pipette on, as he's telling me here, it would automatically show up as another option to execute this protocol. In the interest of today's demonstration, Andrew Plus is of particular interest, so we'd want to show you how it actually works. So here's the material that I'll need. I'll click on continue, and here we are. We've now really come full circle to what writing a protocol looks like, to how actually executing it with instrumentation looks like. And this is what it looks like. So without programming a robot, I just created a protocol. Without programming a robot, I essentially, well, programmed a robot. So here it is. The system is asking me to place these dominoes. So these magnetic blocks I mentioned in the very beginning, these dominoes that are in my video feed, just now simply need to be placed in front of the instrument as shown by this bird's eye image on my screen before being able to launch and start that experiment. So position 1, some tips. I just need to refill my tip box with the correct number of tips as requested. Step 2, same thing, but with a large volume tips. Position 3, a microplate domino. Position 4 is red. This means that we as operators need to validate a starting volume so that the robot knows where to go before pipetting. So I'll just need to update this volume with what I actually have in my tube. Check that volume is actually correct. In position A1, some water. And now there we go, we can click on Start Experiment. And essentially, if I were to do this right now, so I could, I won't do it, because essentially it'll just come around to what I had just shown you at the beginning of this conversation. The robot going, doing his checks to making sure that everything is in the correct locations as specified by the software, and then just getting started. So taking the right pipette he needs and pipetting away. So I hope what I showed you today was clear, comprehensive. Did want to keep it relatively short and sweet. So thanks for your attention. Of course, if you need more information, feel free to reach out directly to us via our website, andrewalliance.com. Thanks for your attention and have a great day. Bye-bye.